Welcome to Chapter 7 of the Raymarching Shader in Unity tutorial by PeerPlay. In this part I will teach you how to add Penumbra shadows to the Raymarching Shader and create this scene writing some more functions in the signed distance field. So far we made the Raymarching Shader appear in the scene view and implemented a simple Lambertian lighting model. To create a convincing 3D scene, shadows are a must-have, and the characteristics of the shadows greatly influence the atmosphere of the rendered scene. We will create two different parameters for the shadows. First of all, the strength. How dark or light are the casted shadows? The second parameter is the penumbra. This creates soft shadows by calculating a fall of shadow of rays that nearly miss the surface between the point and the light direction. In this first video of 2019, I hope to continue creating high quality content and keep improving on my teaching as well as editing skills. If you find the contents of my tutorials helpful, consider supporting me at Patreon. In doing so, you enable me to continue creating these for my peers and you get access to the tutorial source files and exclusive content. Special thanks to Andrew Laboy, Devin the Dude, Derek Fegter and Patrick Nugent. Let's continue where we left off in the previous part and create the scene from the introduction of this video. Let's open up the Raymarching Shader. In the scene that we'll create, we don't need to use the fmod function, so let's remove the first three lines of the distance field. To show the shadows casted on the ground, we'll create an infinite plane. I added the SD plane primitive distance function. This function requires a position and the normal plus offset parameters. Let's now implement that into the distance field. So we'll type float and we'll call this ground, and that is going to be an SD plane with the position of P, and with the normal we'll put in a float 4 of 0, and we want it to point upwards, so for its Y it's 1, for its Z it's 0, and the offset will be 0 as well. Now let's just return the ground for now, so return ground. Let's save the shader and go back to Unity. Back in Unity you now see an infinite ground plane. And of course it's not infinite because we've set a max distance, so if we increase or decrease the max distance, you'll see that the ground grows or shrinks. Now let's create the box sphere object from the introduction scene. If you want to model a certain object, a nifty way of doing this is to create a local float function for this object, so you can call upon this float in the distance field function. So above the distance field, let's create a new float. And we're going to call this the box sphere. And this will have an input of a float 3 P. Now let's place the sphere and the box lines inside of the box sphere and remove them from the distance field. And in the distance field we can call upon this function box sphere. So we can say float box sphere 1 is box sphere with the position of P. Now inside the box sphere we can model our box sphere. Now instead of creating a box with hard edges, we will create a rounded box. We'll be using this as the roundbox function. You can pause the video to write this out or find this included in the source files available for patrons at my Patreon. Now let's change the function of box1 to SD roundbox. And this requires a third parameter for the rounding, and we'll make this variable available in the inspector. So let's add a uniform float and we'll call this the box1 round, and let's add that value to the equation. In the previous part we subtracted the sphere from the cube. In this case however I want everything to be smooth. I added these three smooth Boolean operators for union, subtractive and intersection. So let's implement the smooth subtractive operator into the distance field. So let's create a float and we're going to call this combine1, and that is going to be the opIS, and we're going to subtract the sphere 1 from the box 1 by a certain value. And for this operator, we'll add another public variable. So let's scroll to the top and we're going to add the box sphere smooth. Let's copy that and put that into the equation. Now I also want to create a rounded outside of the object, and for that we'll use a second sphere with a smooth intersection operator on the result of combine 1. So let's copy paste the line sphere 1, and we're going to create sphere 2, which is gonna use the sphere 2 variables, which we still have to create. So let's create them here. So sphere 2. And now we'll apply the intersection operator. So let's create a float and we'll call this combine 2. And that is going to be the operator of the intersection smooth. And we'll do that on the sphere 2 with the combine 1. And we'll create a variable that is called sphere intersect smooth. Now let's create this variable. So let's scroll to the top and paste it there. Now let's go down to the function again. And the only thing that we require is we need to return a float. So we'll type return combine 2. Now in the distance field, we're just returning the ground, and we need to return the ground and the box sphere. So we can return with the operator union the ground and the box sphere 1. Now let's save the shader and go to the Raymarch camera to add the new variables. Let's remove the mod interval, we don't need that anymore. Let's put the box 1 on a new line. So let's say copy this, paste it, put this to a box 1. Let's also create the sphere 2. Let's actually put the sphere 2 underneath the box 1 because it's applied at the end. Now let's add a public float for the box 1 round. And let's also create a public float for the box sphere smooth. And at the end, let's also create a public float, and we'll call this the sphere intersect smooth. So now let's implement them in the on-render image. So we need a new sphere. So let's add one, sphere 2. And we need a couple of new floats. So we've got a float here. Let's copy them 3 times. And we're going to replace this with box 1, box sphere smooth, and the sphere intersect smooth. Let's actually create a header above of these variables. So let's type header, and we'll call this signed distance field. Oh, and we removed the mod interval, so we need to remove this line as well. Now with that in place, let's save the script and go back to Unity. Now we don't see anything yet because all the parameters are set to 0. Let me quickly set the parameters to the ones I used for the introduction. So these are the values I used, but I advise you to play around with the parameters because it's a lot of fun. For example, if we change the sphere intersect smooth to a negative value, you'll see this as a result, and then you can see what the result is of the box 1 round. And you see this changing to something else, or change this value, and see what we can create with that. So now that we have the distance field set up, we can start to create the shadows. To keep everything nice and organized, we'll create a float3 function for the shading instead of writing everything here. So above the Raymarching, let's create a new float3, and we'll call this shading. And we're going to input a float3 position, and we're going to input a float3 for the normal. Let's copy this equation of the light to the shading. And instead of this line, we're going to call upon the shading. So we'll say a float3 and we'll call this S for shading, is going to be shading with P and N we're going to send to the shading. So inside the shading function, we're going to do everything that has to do with the directional light, shadows, ambient occlusion, reflection, and so on and so on. So let's start by doing the directional light. And I'm going to add a couple of things to the directional light to make this equation a little bit better. There are two things I want to add to the directional light. One is a color of directional light and the light intensity. Let's change this float to the name of result, and we're going to create a color parameter. So let's say that we call this light call, and we still need to create the float 3 for that. And we're going to multiply that by the dot product. And we want to multiply this by some light intensity. So let's create a light intensity. Now to make this multiplier work, we can do a little trick. So I'm going to put parentheses around these, and the result of this equation, we're going to multiply this by 0.5, or we're going to divide it by 2, and then we're going to add 0.5 to that result. So the way this works is if we have an output of this dot product of 1, if we divide this by 2, we get 0.5 plus 0.5 will become 1 again. But if the output of the dot product is 0, then this will make sure that the result will be 0.5 and we can use the multiplier on it. Now let's add the light call and the light intensity as variables in the shader. So we're going to say a float 3 of light color, and we need to have a float value for the light intensity. So let's say uniform float is called light intensity. Now let's finally add the shadows to the scene. So we're gonna type shadows, and we'll first create a function for hard shadows, and once we've implemented that, I will show you how to calculate penumbra or soft shadows. So let's create a float function outside of the shading, and we'll call this hard shadow. And this hard shadow function requires 4 different parameters. We need to have a ray origin, the ray direction, the minimum distance for the shadows, and the maximum distance for the shadows. So let's create a float 3 for the ray origin, float 3 for the ray direction. We'll create a float for the minimum distance traveled, so min t, and a float for the max t. So how does the calculation of shadows work? We've already used the ray origin and ray direction to view this signed distance field. The ray origin and direction were the camera itself. Now for the shadows, we will march from each point of the distance field. Let's take the white sphere as an example point, but the shader does this on all points. The ray origin is this position, and the ray direction is the inverse of the directional light direction. If this ray hits a surface within the minimum and maximum shadow distance, it will output a value of 1. If not, the output value will be 0. Let's first call upon the hard shadow inside of the shading. So let's create a float, and we'll call this shadow, and that is going to be hard shadow. And we need to get the ray origin, and that is going to be P. The ray direction is going to be the minus value of the light direction. And for the minimum and maximum distance of the shadow, we'll create a float 2 and use the x and y components to specify this. So we'll create a shadow distance.x, and we'll use shadow distance.y. Let's quickly add this variable to the shader. So we're going to create a uniform float 2, and we'll call this shadow distance. Now onto the hard shadow function, we need to create a for loop in which we'll do some sphere tracing. So we'll say for float t, which is the distance traveled, is going to be the min t. And as long as t is less than the max t, the for loop will continue. Now we need to march on the distance field, so we're going to say float h is going to be a distance field. with the ray origin plus the ray direction multiplied by t. Now remember that if this value returns a value below 0, then we are inside a distance field object. So we need to do an if statement to see if we've hit something. So if h is less than 0.001, then we need to break out of the function and return 0. So we'll say return 0.0. Now you might ask yourself, why is this 0 if this is a shadow? Well, we will multiply the color by the result of this equation. So a color multiplied by 0 will become black. So that's a shadow. And if our ray hasn't hit any object, we want to return 1. So we'll return 1.0. Now that's it for the hard shadow function, and now let's implement this into the shading. Now just as we did with the lighting, I also want to create a shadow intensity. So we're going to multiply this by 0.5 and we're going to add 0.5 to this. Now I want to be able to set the shadow intensity. So we're going to say that shadow is going to be, and we're going to create a variable for the shadow intensity and set this shadow to the power of that. So let's type power of the shadow that it is to the power of shadow intensity. And to make sure that the shadow is at least 0, we're going to put a max around this of 0.0 to the result of this equation. Now we only need to apply the shadow, so we're going to say that a result multiply is with the shadow. Now we can return the result. Now let's scroll down, and here we apply the main color multiplied by the light, but we've changed this to the shading, so we'll multiply this by S. Now we also still need to create the shadow intensity, so let's scroll to the top and create a uniform float, and we'll call this shadow intensity. Now let's save the shader and implement these variables into the Raymarch camera. Let's organize these variables a little bit. So let's put the max distance above here. Let's create a header for the light variables. So header, and we'll create light, or let's call it directional light. Let's also create a header for the shading. So header shading. So we implemented the light color, so let's create a public color, and we'll call this the light col. Now let's also create a public float, and we'll call this the light intensity. Let's actually call this, instead of shading, let's call this shadow, and let's put this one underneath the signed distance field. Now let's start with a public float for the shadow intensity. And we have the shadow distance, which is a vector 2. So let's create a public vector 2. And we'll call this the shadow distance. Now let's implement the variables that we've added into the shader. So the light color, we need to set a color for that. So let me copy one of these lines. And instead of set a vector, set a color. And we're going to set the color of light col to become light col. Now the light intensity, we need to have a float for that. So let me select a float here. Let's set the float of the light intensity. Light intensity, light intensity. And also create one for the shadow intensity. And for the last one, we need a vector. So let's copy that and paste it under here. And we're going to get the shadow distance. So we're going to set the shadow distance to shadow distance. Now let's save the script and go back to Unity. Now back in Unity, everything is black because we still need to set all the variables. So let's change the light color to something like a little bit yellow. Light intensity to 1. There we go. shadow intensity, let's set this to 1 as well. The minimum distance and the maximum distance, we need to increase that. And now we can see some shadow. And you should set the minimum shadow distance to something higher than 0, because otherwise you get these things here. So let's set it to 0.1. Let's change the main color of the signed distance field to something a little bit nicer. And we can increase or decrease the shadow intensity. Now if we select the directional light, we can rotate this around and you can see that the shadows are changing based on the light direction. So now that we have the hard shadows working, let's create the Penumbra shadows, which is a really easy step and doesn't cost any more processing than the hard shadows. Let's copy paste the hard shadow function. And we're going to rename this to become soft shadow. We're going to add one more parameter and we're going to call this float k. And this float is going to be the Penumbra parameter that we can set. At the top of the function, we're going to create a float and we'll call this result, and that is going to be 1.0. To create the Penumbra shadows, instead of returning 0 for the rays that don't hit any object, we return the value of the closest distance it came to an object. This value was already calculated in the hard shadows, but we simply didn't use it. And we can implement this by writing one simple line. So let me type out the line. So result is going to be the min of the result itself to k multiplied by h divided by t. And instead of returning 1, we're going to return the result. So by using the min operator, we always get a value between 0 and 1. The higher the value of k, the Penumbra value is, the more chance the resulting value will be below 1 and thus resulting in a shadow. So let's now implement the soft shadow into the shading. So instead of hard shadow, we're going to return here the soft shadow. We need to add another parameter. And for this parameter, we're going to create another variable. So let's call this the shadow Penumbra. Now let's add the shadow Penumbra to the shader. So scroll to the top and we're going to add a float for the shadow Penumbra. Now let's save the shader and go to the Raymarch camera again to implement the shadow Penumbra. So let's create a public float and we'll call this shadow Penumbra. Let's actually make this a range. You can do this for all of the different variables. And we're going to make a range between 1 and 128. Let's actually create a range for the shadow intensity as well. So between 0 and 4. Now let's implement the shadow Penumbra in the onRender image. So we're going to get a float. And we're going to get the shadow Penumbra and change this to shadow Penumbra. Now let's save the script and go back to Unity. And back in Unity, you can now see that the shadow Penumbra is working. We already see some soft shadow here and we can increase this number to anything we want. Set the intensity higher, maybe set this very low. Create some nice atmosphere. So as you can see, shadow does a lot for the atmosphere of the scene. In the next part, we'll continue with extending the Raymarch shader with more cool functions. Thank you for following this part, it was quite a long one. If you found this helpful, feel free to share this video with your peers. To stay updated to new released parts, subscribe to the channel and turn the notifications on. Happy coding!